Okay, we've got just 40 attendees now, so we'll make a start. We're 2 minutes past, so we'll make a start and we'll let other people join as they come in. So good afternoon, everyone. My name is Charlie Law, and welcome to this PEFC Timber and Carbon CPD. So yeah, my name's Charlie Law. To give a bit of background on myself, I've worked in the construction industry for over 35 years now. 12 of those were spent heading up environmental management at one of the UK's largest contractors, BAM Construct UK, where, like I say, a lot of my time was looking at responsible sourcing, hence the role in timber today, as well as things like circular economy. And I'm now also the number of jobs, but one of those is the Sustainability Director at Timber Development UK. What we're going to cover today, we're going to look at why we should measure carbon, carbon-related impacts of timber, how we calculate them, the importance of responsible sourced timber within carbon calculations, and we'll look at how we maybe assess carbon in timber EPDs and assessing carbon in buildings slightly separately, and then look at how we can reduce that embodied carbon through things such as circular economy, and we'll touch on the timber industry net zero roadmap as well, and other information to show what the timber industry is doing to try and reduce that impact. And obviously, by the end of that, hopefully you'll have a much better understanding of timber and carbon, and we'll be able to issue you a CPD certificate. So hopefully that's what you're expecting today. So why do we need to measure carbon? I think hopefully we all agree we're in a climate emergency at the moment. Some of the hottest years on record have occurred in the last sort of 10 years or so. And we're currently on course for a minimum 3% temperature rise by the end of the century. And considering, that we set targets for Paris in 2015 to try and keep well below 2 degrees, preferably at 1.5 degrees compared with pre-industrial levels, we're not doing too well on that. And actually, last year we actually breached that 1.5 degrees Celsius average temperature. Alongside that, so that's the international targets, and obviously we know there are lots of upheaval in the international world at the moment, but the UK government still has its net zero target of 2050, which was set in June 2019, and there's now an interim target which was announced at COP29 last November, where they're looking to make an 81% reduction by 2035 compared with the 1990 levels. So the UK is doing pretty well, and it shows that it can be done. And we can see big reductions in CO2 emissions if we do get the right policies in place. Key document that was issued earlier on this month is the Timber and Construction Roadmap. This roadmap supports, the word from the minister there, this roadmap supports the government's ambitions for a circular economy and a sustainable low carbon future. And obviously they recognise that the built environment accounts for around 25% of the UK's carbon emissions. So by increasing the use of timber, which obviously sequesters carbon, we can significantly reduce these emissions to achieve their net zero goals by 2050 while stimulating the UK economy. So that's what the government is saying around it. But obviously, to be able to confirm that we're doing that, we need to be able to measure carbon as well. People like Letty have been pushing this for a long time. So their climate emergency design guide has targets in it on what we should be pushing for. And obviously the Climate Change Committee, one of their progress reports basically says we need to develop plans to rapidly scale up levels of wood used in construction and support the assessment and benchmarking of whole life carbon in buildings. So that's what the Climate Change Committee is recommending the government should do. The industry agrees, and the industry has proposed this Part Z amendment to the building regulations. This isn't actually a building regulation at the moment. This is a mock-up developed by the industry, which outlines, how the requirements on assessment of whole life carbon emissions in buildings could work, along with limits on the embodied carbon based on amount of carbon per square metre of floor area. So everything is pushing towards us measuring carbon in buildings and construction going forward. How does that impact on timber? Don't want to teach you at snack eggs, but going back to our old biology lessons back in high school, obviously trees take CO2 out of the atmosphere. They absorb the carbon and emit the CO2 back into the atmosphere. And that's where that 750 comes from. An average piece of softwood stores around 750 kilograms of CO2. It's basically 50% of the dry mass of timber is biogenic carbon. And that's based on the studies that TDUK have done, and we've just released that, and I'll go into that a bit more later on. But obviously that carbon as well, that's a physical carbon that stays locked up in that timber, no matter how many times that piece of timber is used or recycled. That carbon stays locked in the fibres of that timber. So as long as we can use that timber for in construction for a long amount of time, recycle it, reuse it an infinite number of times, the only way it can be released back into the atmosphere is if it decomposes or we burn it. And a lot of the timber, waste timber we use is burnt, but obviously that's balancing the carbon emissions from when it first came out. So in effect, you get a carbon balance across the life cycle. But over that period in between, it could be a couple of 100 years, could be 300 years. If it's the door in Westminster Abbey, it's 1,000 years. That carbon is being stored. However, going forward, it's likely we're going to have some form of carbon capture and storage. And then we can not emit that carbon when we burn it at the end of the day. So that becomes very much a carbon removal mechanism going forward. So just looking at the, some more issues around timber, and this is some more stuff from the roadmap where the government is saying, look, it understands this, and we need to improve and increase the amount of homegrown timber that we're using, and we want to increase the canopy cover from 14.5% to 16.5% by 2050, and we also need to promote low carbon timber and support timber in construction going forward. And the reason for that is obviously that it's not just the timber in construction that's storing carbon, it's the actual forests themselves. So this is from the Forest Europe report, shows that in Europe, we've got about 227 million hectares. It's around 35% of the total land area. And that is storing in the forests and the soils, is storing about 135 billion tons of CO2. With a net uptake of currently estimated at around 570 million tonnes per year being taken out the atmosphere by those forests. So a lot of biomass being there, and 40 million tonnes of that being stored is actually in the built environment. So that's what we call these harvested wood products. So that's harvested wood products generally used in buildings and construction. If we look at that for the UK, we can see obviously we've got a lot lower forest cover in the UK. It's only about 13% overall. If you look at that green line at the top, that's the harvested wood products. Because we're importing a lot of timber into the UK, the harvested wood products makes up a lot larger percentage of the stored carbon in the UK. So it's about 4.2 million tonnes being stored overall. In woodlands, at around 20 million tonnes per year take up, with a significant around 400 million tonnes being stored in those harvested wood products. So as far as how we measure that carbon, there's two key documents that we need to look at for construction products. Is 15804 is the actual products, the core rules for product category rules for construction products, and that's really around the environmental product declarations that are produced for individual products. And then you've got BSN 15978, which is the sustainability of construction works, the assessment of environmental performance of the building. So that's obviously taking the information from the EPD for the product and then ramping it up and multiplying that up for the works in the building. The standard itself is quite basic. So what the IFCS have done is produce their whole life carbon standard. So whole life carbon assessment of the built environment. That's now in its second edition, which sort of basically gives a lot more guidance on how you can do that for a building. And in effect, the way it works, if we take this graph for timber accounting, we've obviously got it takes what we call the backward approach, and to try and explain how this works. So we've obviously got our timber is growing in the forest 50 years before it's harvested and used as timber. So over that time, it's taking carbon out of the atmosphere. So that's 750 kilograms of CO2 that we talked about. So that's the line coming down here. Obviously, when it's felled and processed, there's a carbon impact of that. But overall, there's a net negative figure of carbon in held out the atmosphere. There is another school of thought which talks about using the upfront carbon, which does cause a few issues because there is a missing carbon gap. So it's not something we promote, using that carbon, taking the upfront carbon and discounting it over a number of years. It just doesn't really work. So what, and the standards agree with us, actually, because if you look at the way the standards work, they do take that up front. So when you do your assessment for your building, you take the biogenic carbon into account when you're doing a whole life carbon assessment at the point of construction. Obviously, there's a upfront impact there. What it does do, the standards do say, though, is you must work out that whole life carbon assessment over a 60-year period. So you end up having to add back in that biogenic carbon after a nominal 60-year period. Obviously, the building may start for a lot longer than that, but you have to account for it over a nominal 60-year period. So you end up with a figure, a net positive whole life carbon impact figure, which is the true impact of the obviously the processing of the timber, which is fine. But in that intervening period, obviously you're storing that carbon out in the atmosphere. So it can't actually do any damage to anyone, to the planet at that time. And obviously, if that building stays up, that carbon is stored for a lot longer than that. It's not just 60 years. If you can keep that building in place, that carbon is stored for a lot longer. So why is it important that we use responsibly sourced timber within these carbon assessments? Well, the standard basically says why. It says that in 15804 definition of sustainably managed forests, you can only include timber in the upfront assessment, in the A1 of the assessment, if you're obtaining timber from sustainably managed forests. So, for example, sustainably managed and certified forests, any forests which are operating under established certification scheme for sustainable forest management, such as PEFC, obviously here today, but also FSC, UK Woodland Assurance Standard, grown in Britain, for example, would all come under those definitions. You've then got some other options there of possible forests which might be able to be included, but there's a lot more work to do to demonstrate that. And obviously, the reason for that is we are seeing a lot of deforestation still around the world. It's better than it was back in the 1990s. If you look at that graph there from the UN Food and Agriculture Organization, it was down at we was losing about 7.8 million hectares a year. At one time, it's now slowed, but we're still losing 4.7 million hectares of forest a year from the net forest from the world surface. So we do need to reverse that trend very soon, really. There is another table here, a map here, which the UN produced back in 2015. Unfortunately, I haven't updated that since 2015, which is a bit of a shame, because this does show where the hotspots are and where you should be concentrating your efforts if you are purchasing timber from certain parts of the world. So, obviously South America, particularly Brazil, is losing a lot of rainforest at the moment, and it has slowed in recent years since the change of government in Brazil, but it's still not too great. Obviously, sub-Saharan Africa and parts of the Far East aren't looking too good either. Obviously, the big red mark there is Indonesia. Now, Indonesia, since this map has been produced, has turned itself around and is now one of the only countries with what we call a FLEG T license. So they can actually export sustainably managed timber now, and it's there's a lot less deforestation going on in Indonesia. So it shows we can turn things around in these areas. So based on that, what are we actually buying in the UK? What timber do we buy? So the latest information from the Forestry Commission Statistics Report that comes out in September each year. So this one's from September 2024. And shows the data for the previous year, and obviously TDUK import data as well, shows that obviously the vast majority of the wood we use is softwood based. So that's coming from the generally fairly local areas, so mostly from Europe, Scandinavia in particular. So in total, we import we consume about 14.7 million cubic meters of timber. That's about 8.5 million of that is softwood. But significant proportion there, you're looking at just over 4.5 million cubic meters is panel board products or board products that are manufactured from that softwood timber. So things like particle board, OSBs, MDFs are all manufactured from the parts of the tree that are not used for solid timber. We've then got a small amount of hardwood, so sawn hardwood, just under 500,000 cubic meters there. Quite a bit of plywood, which most of that being hardwood plywood, just over 1.1 million cubic meters there, and then a growing amount of what we call engineered timber, which is still less, it's sort of less than just over 1% really. If you look at that, 1.71, which is things like I joists as well as CLT, glulam, LVL, that sort of thing. So we would it's just over sort of 1.5%, something like that. You're looking at there of engineered products now, so quite a small amount compared with some of the crest that gets. The vast majority is still our sawn softwood products. Launch this one. How much of the UK consumption how much that 14.7 million cubic meters do you think is consumed, is sourced from the UK? So most of you think around 20%, which, to be fair, if you were talking about structural timber, that's not far off actually. We estimate that around 80% of structural timber is sourced from overseas, and only 20% from the UK. But actually, when you take into account all the other timber uses such as fencing and pallets and stuff like that, it's actually around 39%, 37 to 39%, depending on the year. So almost sort of 2/5 of the timber we use in the UK is actually homegrown, which some people are surprised around. So yeah, so that's where we are with that. Yeah, so if I do a little breakdown here of where stuff does come from, you'll see that UK amount there, about 5.5 million cubic meters based on the 2023 results. The vast majority of the remainder coming in from the EU, as we mentioned, so places like Scandinavia in the mains, and in particular Sweden, about half of our imports coming from softwood imports coming from Sweden. But you have then got some imports coming in from maybe some of those higher risk nations, so China, Brazil, Indonesia, there, Malaysia, Cameroon, which would be classed as higher risk in a lot of cases, particularly Brazil, obviously because of the deforestation there. So we need to make sure that when we're sourcing from those countries, absolutely, we need to make sure that it's responsibly sourced timber coming in. I say based on today, preferably PEFC. So sustainable forest management is good, and if it's done in the right way, these are some pictures from around the world. So the one on the left is a typical softwood plantation in the UK, where we'll take this is a final thinning after about 35 years, and a lot of that timber there will be going into fencing. Some of the bigger logs will be going into C16 timbers, and then the remaining standing timber there trees will be left until maturity, maybe 35 to 40 years. And most of that will then come out and go into structural softwood, generally C16 in the UK, and that'll be clear felled and then replanted. And that is very much like a crop. It's a 35, 40-year crop, but it is a crop in the same way as we plant wheat and everything for our food and bread. We plant trees for our construction timber. It's just a much longer life cycle, but that's how we've got to think of it, as a crop. Slightly different methods for hardwood. This is a typical picture from a Malaysian forest, where we'd actually do selective felling in those cases, where we'll only take out the amount of timber that forest can regenerate in a period. So in any 1 year, a forest might put on 100 cubic meters of timber. So in that year, that area of forest, we can only take out 100 cubic meters of timber. So you maintain that balance in the forest in that situation. That's backed up by the government's responsible timber sourcing policy, so the TPP, timber procurement policy. So that requires that timber must be and wood derived products originating from only timber from and would derive products originating from independently verifiable, legal and sustainable sources, which can include FLEGT partner products, will be demanded for use on the government estate. They will demand appropriate documentation to prove that, and it applies to all virgin timber and wood derived products used on the government estate, including temporary site works, hoardings, formwork, protection, etc., and obviously all the materials supplied by suppliers and subcontractors, not just the principal contractor. Um, there are two ways of demonstrating that. There's what we call category A evidence, which is independent forest certification schemes, and the two that are noted in the scheme at the moment are PEFC, obviously, and FSC. It's likely that Grown in Britain will get added to that in the next iteration. They're talking about doing an update, and at the moment they have been talking about for the last 5 years about doing an update of this, but we do feel that that's going to be very close now. So, and obviously Grown in Britain demonstrate that timbers come from a UK forestry standard source there, which is a category B evidence at the moment. But you've also got your Fleg T stuff, which sort of sits in between A and B, but I've stuck it in B there for now. And if you can't demonstrate that, then you have to comply with the framework for evaluating category B evidence, which is quite an onerous task. You do not want to be doing that if you can help it, because that is a hell of a lot of work to demonstrate that. So best to go for one of those certification schemes. If you want more information on how to demonstrate that and the chain of custody standard, we do, PEFC do offer, which I deliver, a responsible timber sourcing CPD, and we will have one of those in the diary. So if you check the PEFC website, you can get yourself booked on that. And we go in a lot more detail on chain of custody and how and responsibly sourced timber. So just out of those schemes there, which ones of those have you heard of? So if we just launch this poll. So which of those schemes that we just mentioned there have you heard of? A little bit of an explanation there. Actually, you know, I know FSC sometimes gets a lot of the big press, but actually the biggest forest certification scheme is actually PEFC, because it's it's got about 400 or over nearly 500 million hectares of certified forests. You know, it's a massive amount of forest out there. It's about 500 million hectares, and quite a bit of that is PEFC certified. So if you look at where PEFC is strong, it's very much the northern hemisphere, so North America and Canada. Obviously all of Europe you can see there, as well as parts of the Far East. And when we said that most of our timber obviously is coming from Europe and Scandinavia, it makes sense that we should make sure that we allow that PEFC timber, with FSC very much being dominated by the higher risk areas. So places like Brazil, Sub-Saharan Africa, obviously Russia and Belarus were currently suspended. We can't get any timber from there at the moment. Also parts of the Far East. So, you know, just bear in mind that you know, where you're getting your timber from, you need to make sure that you include all of those schemes to make sure you can get the best opportunity to get certified timber. So assessing carbon in timber EPDs. How do we assess the carbon in EPD? We'll spend the next sort of half an hour going through that, how we do that. So there's a number of stages within an EPD. So we've got the raw material extraction, transporting that from the raw material site to the manufacturing site, and obviously the manufacturing process itself. And that's obviously termed A1, A2, and A3 is what we call the product stage. We then have the construction stage, which is transporting that material to the site of use and obviously putting it in place on the construction site. We then have the in-use phase, B1 to 5, which is use, maintenance, repair, refurbishment, and replacement. There's the operational carbon phase, which is sort of part of the use phase in effect, but it's where we talk about operational energy and water, so B6 and B7. And then we have our end of life stages, so deconstruction or demolition, transportation off-site, and then any processing and possibly disposal if it is going into things like landfill. So that's our main stages. We also have our D stage, which doesn't form part of the calculation, but sort of explains the benefits beyond the life cycle. So, you know, the benefits of recycling or using as biomass or whatever it may be. But like I say, that bit doesn't form part of the calculation. Now, when we talk about embodied carbon, what we're talking about is the everything but, in effect, the operational carbon. So A1 to 5, B1 to 5, and C1 to 4 is what we call our embodied carbon element. Obviously, we've got the operational carbon is B6 and 7, as we mentioned. But sometimes you might also hear, so all those added together is your whole life carbon assessment. So embodied and operational is a whole life carbon assessment, but you might sometimes hear the term upfront carbon as well. And that's where we do an assessment based on just up to the point up to practical completion, so A1 to 5 only. So a few terms there that you might want to look at. If you want to read up on those, there is a good glossary on the TDUK website if you want to read up what those terms actually mean and remind yourself. So those a typical EPD, we've got one here from Store Lorenzo. So Store Lorenzo, you'll see within that EPD there will be a table in there, quite a few tables actually, but a couple of main tables. The first one there is the biogenic carbon content, so how much carbon is actually within the product when it leaves the factory. So in this case, we can see it's around 733, so just a little under that average that we mentioned, around 750 earlier on. So around 733 kilograms of CO2 in this product. But then you'll also see the environmental performance product at the product stage, and then obviously there'll be these tables for all the different stages as well. And the main one in there, obviously, it's not just about carbon. This obviously we've got a few areas. We're talking about global warming potential, ozone depletion, etc., etc. But the main one most people are interested is obviously that global warming, and that's made up of 3 key bits, which is fossil carbon, biogenic carbon, and land use change or transformation. Okay, and they add up to the total global warming potential. Okay, so just to give you a few ideas on how on the sort of figures that you get from these sorts of EPDs. So A1 is the extraction of the raw material, excluding the biogenic carbon in this case. So for this EPD, for the Store Lorenzo EPD, is around 12 kilograms of carbon. So very little carbon emitted during that extraction phase. So that's obviously things like planting the trees and growing the trees and then extracting them at the end with harvesting them. Transport is probably the biggest emission in the timber supply chain. So transporting that timber from the forest into the sawmill is gonna be the key impact in most cases. You've got about 17 kilograms of carbon there, and then the actual manufacturing stage, particularly if they're using things like biomass energy for their kiln drying. So when they dry the timber, they use the kilns and obviously have to heat them up. If they're using biomass, that's classed as carbon neutral. So if they're using that, and then obviously some of the Swedish mills are using sort of hydroelectricity and stuff like that, you can really get those manufacturing emissions quite low. So that's actually the actual manufacturing of the timber is actually a very low carbon resource. So upfront carbon there is obviously quite low. You've then got to get that material to the site. So the A4 emissions on this particular example might be around 38 kilograms of CO2, because obviously you're shipping it from Sweden into the UK. So you've got that shipping emission that you need to take into account there. And then you've obviously got use on site, which not too much data on this at the moment. It's been estimated around, in this EPD, around 15 kilograms of CO2e per cubic meter. But obviously that should be a lot lower than other materials, because you can use things like smaller cranes, for example. You wouldn't need such a big, heavy crane to lift the materials into place, because timber has a low strength to weight ratio. So you've got a much lighter product that can go in place. It's going to do the same job as a heavier product, say concrete or steel, for example. So you can have a lot less plant on site or smaller plant on site to do that job. In use phases, timber really doesn't have any impacts in use if you specify it right and can make sure, through the example, the timber frame, that's going to be left in place for the whole of the project. You might need to think about external cladding elements to make sure they can last the life cycle, to minimise the impact on maintenance and repair or replacement in certain cases. But generally, timber will last can last the length of the product, the 60-year life cycle that we talk about. We've then got the end of life, which again are quite low, because the timber doesn't usually travel far from the site of use to the place of treatment. So it's generally quite low mileage emissions there. So you've got a bit under deconstruction. The transport again is the main emission, and then you've got some waste processing. And like I say, in most cases that will be chipped into one of the 3 here. It'll be either reused, maybe not so much at the moment, but that's something we need to look at. Quite a bit is recycled, It might go into biomass, and we've got some figures later on which show you the breakdown, or it goes to landfill. And the EPD will probably give you a figure for each one of these in some cases. So the Stora Enso one does actually give this broken down for each type, for each impact. Beyond the life cycle assessment, we need to look at the benefits and or burdens of accruing repurposing elements from discarded built environment asset. So things like, for example, reuse of engineered elements or the use of recycled wood chip for paddleboard manufacture obviously avoids that production of new wood chip and new softwood timber. So if we're using that, that reduces the impact from that original harvesting, for example. So that's what we're talking about in Module D. So that's why we need to look at how we can, in most cases with timber products, cascade the reuse. So we've got the timber coming in at the top. We've got our mass, might be our mass timber that might be able to cut down and be reused as reclaimed timber. Timber elements such as glulam beams or something like that might be able to get reused in other smaller buildings. We can then chip that material into panel boards, maybe chip it again, and it might go into things like insulation. And then we can then, at the very end of its life, we can then burn it and extract the energy from that product to make electricity. So, and then obviously that then CO2 from that process then gets reabsorbed back into the trees that are growing. So assessing carbon in buildings is very similar. So that's the EPDs, but the building is exactly the same graph here or table. We've got the raw materials coming in, we've got the on-site construction emissions, the maintenance, the operational, and the end of life stage. So exactly the same sections of that life cycle assessment for buildings. Just a quick question. So when assessing the embodied carbon of an asset, when can you include the sequestered carbon within the timber product? Share the results. Most of you got that right. So yeah, when carrying out a whole life carbon assessment, i.e. A1 to 5, B1 to 7, C1 to 4, and D, and all the timber is sourced from a verifiable, sustainable source. So absolutely correct there, those ones. And that sort of leads back to what we were saying before around the sustainable timber element. So this is how you treat the sequestered carbon in timber products. So whole life carbon assessments, as we said, A1 to 5, B1 to 7, and C1 to 4 and D. You can include that negative biogenic carbon in A1. So for example, the average for softwood, you could include a figure of minus 750 in there for the carbon, and obviously the impact of the timber production itself. And then you add back in the transferred carbon at the end of life in C3. So you add back in that biogenic carbon. It's usually in C3 because it's going to go either for recycling into things like panel boards or going into energy from waste. So it's transferred out of the system at that time. So it's not emitted to air. It's not emitted to atmosphere at that point. It's transferred out of the system into another product. And that other product would be either, like say, panel boards, animal bedding, for example, might be another one, or biomass energy fuel. And it's the biomass energy fuel that then takes the impact for burning it. If you're only doing the upfront assessment, i.e. A1 to 5, which I know a lot of people would do for their clients, you don't include the negative biogenic carbon in A1. So you must omit that from the calculation and only include the fossil and land use and land use change emissions in the calculation, not the biogenic element of it. Okay, so you'll always end up with a plus figure then for the upfront carbon assessment for your timber in A1, but you must state that biogenic carbon separately as stored carbon. So that's 750 kilograms of CO2 per cubic meter that we mentioned earlier on. You state that in the calculation, saying that this building or these elements are storing this amount of carbon out of the atmosphere. And obviously, like I say, all timber must be from verifiable, sustainable sources of PEFC, FSC grown. If you want to look at some of the data, because obviously when you're doing your upfront assessment, you might not know exactly what timber you're using at the time when you're doing your initial assessments. We'll point you in the direction of the TDUK embodied carbon data. So if you go to the TDUK website, you'd be able to click on the embodied carbon data for timber products. And it will have this table in there which shows you the average the average emissions, so the embodied carbon emissions of lots of different timber products, including the biogenic carbon and excluding the biogenic carbon. And it also includes the A4 transportation emissions as well from the place of production to a nominal place in the UK. So, which is much more accurate than the tables or the calculations that you use in the RICS professional standards. So we'd employ you to use that if you can. Basically, I say product stage, you include exactly the same stuff. So from A1 to A3, you probably, if you include it, just doing an upfront assessment, you're probably looking at around 74 kilograms of CO2, if not less, on some of the other timbers now. Transporting the site is about 40 or 50 kilograms in a lot of cases. Construction site emissions, you'll have to estimate, and that'll have to be based on data that you're looking at for the site itself, but something you have to calculate from the RICS table there. Maintenance, obviously, if you include in materials that are going to last a long time and last for 60 years, there won't be any generally be any sort of replacement or refurbishment costs. You might have some maintenance if you've got a coated timber product, so whether it's painted or varnished or oiled or something, you might have to do some maintenance to it. It depends on the type of timber. This one here is actually a brimstone product. It's a thermally modified timber. That wouldn't, you just leave that. You wouldn't need to treat that at all, and that would last for 60 years, for example. And then for your end of life phase, overall, you could include these figures for your calculations. So around 67% of timber ends up in fuel for biomass, around 24% in recycled panel boards, 8% in animal bedding, and less than 1% goes into landfill. Okay, so if you wanted to include a split, that could be your split overall for timber products. If you want to go in a bit more detail, there is a table in the TDUK papers and the RICS professional standard, which gives you some more a better breakdown based on the type of timber that you're using, whether it's engineered or whatever it might be. Okay. And obviously, one of the key bits that we need to look at when we're looking at reducing embodied carbon is looking at timber and the circular economy. I will whiz through some of this because I know we've got some questions that have come in, and I will get to those before the end. But timber and the circular economy. So, circular economy, we do another course on this. So I won't spend too much time on this. I will rattle through this. But basically, looking to keep the timber in use at its highest level. And timber does sort of fall between, if you look at the Ellen MacArthur Foundation, between technical nutrients and biological nutrients. We want to try and keep it in use, maintain it, reuse, redistribute, refurbish, remanufacture it, and recycle it at the end of life. But then it'll probably go into the biogenic cycle where it goes back into the biosphere at some point. But what we do need to try and do is minimize that energy recovery element, because obviously that once it goes to energy recovery, we've lost that product and have to then grow a new tree, basically. Whereas if we can keep reusing that existing timber fibre, it's a much better way of doing it. So one of the options I think we need to do is we need to obviously design out those fossil fuels. We need to move to more renewable energy for our production processes, and that might include some biomass for timber, for example, for the heat that we mentioned. We need to look at our business models and whether we actually carry on selling product or whether we look at lease or service contracts. When we install the product and manufacture, we need to make sure we're recycling all the waste from that process into other products. And once we've installed the product, it's being used, we need to make sure it's maintained in place, so it keeps it there for as long as possible. And when it does get to the end of its life, we deconstruct it, disassemble it into its component parts as required, and try and reuse those component parts rather than first send them for refurbishment, remanufacture as a second option. And as a last resort, we should be putting them in for recycling, preferably closed loop, but if it is open loop, we need to make sure there is a defined use for that recycler going forward. And actually, timber is pretty good at this, actually. This is a diagram that was produced back in 2009 by CEI BRA, which is the European Timber Industry Federation. And I've adapted this and added some more arrows to it. Basically, this shows that actually timber is quite circular at the moment. We do use a lot of the product Unfortunately, quite a bit at the moment is going into that biomass element. So 67% there. So it's not too far. About 67% going into biomass. We're not too sure what's being reused and refurbished because there's no data for that. But we've got that 24 going into panel boards and 8% in the round wall bedding there. So it's quite a circular process. So designing for reduced carbon, including that circular economy principles. First thing we need to think about is, do we actually need a new building? We need to assess the embodied carbon early to maximise the reduction opportunities. We need to optimise the building form and layout and simplify the design. Incorporate circular economy thinking to ensure maximum reuse. Review that embodied carbon of different structural solutions. So do we do timber? Do we do steel? Do we do concrete? Compare whole life carbon of the building servicing options as well, because the services can have quite a bit of impact. Consider the benefits of carbon storage within the building. So if everything's equal, is our building storing more carbon than an alternative if we use more timber? Focus on those hotspots and obviously make sure we're reducing waste and ensure the maintenance is as simple as possible. So a bit of an example here of reusing existing structures. This is the Allende HQ in the Netherlands. Lots of existing concrete buildings built, I think, in the 1980s onwards. And what they've done is refurbish all those buildings using a lot of timber cladding and insulating them up to modern standards. And this is the inside atrium arched impression, and that's actually the finished building there. So all these timber bits poking out the sides, that's those old concrete buildings that you saw previously. We can optimise design for optimal service life. So whether we use durable timber species, chemically treated timbers, for example, for our structure, just be aware that chemical treatments could limit that future reuse. So, only use them where we need to use them. Things like thermally modified timbers or chemically modified. So things like Accoya, Kebony, which use alcohol or vinegar to, in effect, pickle the timber to make it last longer. So these options might help you increase the life of the timber products. We can design for optimal service life through making intensity of reuse greater. So rather than using a timber panel hoarding and using it just the once and throwing it in the skip, use something like the hoarded system here, which means you can actually take that timber panel out, store it somewhere, and put it back up on another site. A key example here, and that example doesn't penetrate the timber, so it's very little, so no moisture can actually get into the timber and cause it to degrade. So that timber panel there lasts a long time. Pallets is another one. Single-use pallets, 20 million single-use pallets are used in the UK each year. That's now being changed. The Pallet Loop has launched in the UK last year, and they're now supplying around 2 million, about 10% of the pallets in the UK market to construction companies. So so a massive change there, and that's a reusable solution which can cut carbon if everything goes well, and we get a lot, and they get a lot of return rate. High return rate, around 80%. That will cut carbon in the emissions in the industry associated with pallet transport by probably around 40%. Design for ease of maintenance. Make sure we can get to anywhere in the building. So or use products and timber products that don't need any maintenance. For something like this brimstone, for example, if you leave that to weather, it weathers to this silver grey fleece here. That's quite all right. That there's no degradation of the timber in that situation. You can see there that's after about 12 months. There's no movement in that timber anyway, as well. Very low movement in the thermally modified and chemically modified products there. We need to looking at flexibility, deconstruction, and disassembly. So things like reusable connections for structural timbers or even timber flooring. This is a car system which you can dismantle and take up and reposition elsewhere, and you can actually sand that down into the new finish. Or make the buildings more flexible themselves. It's the Vitsu factory, and it's designed to be a flexible space. So walls and units and things like that can be moved around in lots of different configurations. Or make the building totally dismountable. This is the ABBA Arena. If you've been to the ABBA show in London, that whole building is made up of about 1,600 panels that will all fit in a shipping container. So they can all go into shipping containers and be shipped anywhere in the world, and that whole building reconstructed. An example of how that has been done is Ostermarshallen in Sweden, where they took a PEFC certified Curto LVL beams and glulam columns, made this temporary structure that was there which took about 5 weeks to put up, which was used as a temporary market while they was refurbishing the existing market. Once that project finished, this building was dismantled, and it was actually moved 500 kilometres southwest and been converted into a sports hall. So shows what we can do. So timber industry, as well, is doing a lot of work. Timber industry has produced its net zero roadmap. That was published in January 2023 and shows the flows of different materials in the timber industry, quite a bit of it being biomass, which was excluded from the roadmap because that's not, this is the stuff coming in and being burnt in places like Drax, for example. The key bit we're focused on is this element here, which is the timber supply and the waste coming out of the timber industry and how we can reduce the emissions associated with that. It is quite circular, as mentioned earlier on, but the key emission there you can see is the transport emissions and obviously emissions associated with imported timber. Some of that will that's obviously the processing and things like that, and the kiln drying in other countries. So the target is to reduce that from around 5.5 million tons of emissions down to around, obviously around 10% of that by 2050 is what we're aiming for, with the majority of that remaining carbon emission being from the imports of timber. So it's really focusing on making sure we can get the UK emissions down to near zero, so that anything coming in from overseas that may have a carbon emission associated, we can try and reduce that further. Number of key bits. I won't go through this; they are all in the roadmap. But it's basically reducing emissions across lots of different areas, and part of that is obviously trying to make sure that we, measure our embodied emissions in the products that we use, and obviously that's about how we assess carbon-related impacts and benefits of timber and construction products, and also the timber and embodied carbon paper. So a couple of these papers sort of explain how we measure that carbon and how we can then use that information and the information from reducing our emissions in the supply chain to reduce that carbon in that timber product. So we've got about 5 minutes call to action. Hopefully, trust you now better understanding of timber and carbon and how we can reduce our whole life carbon emissions for your projects. Key actions I think we need to look at: assess the embodied carbon early to maximise the reduction opportunities. Ensure you source your timber responsibly, like say PEFC, FSC grown in Britain, for example, to ensure you can include that biogenic carbon in your whole life calculations or state the stored carbon figure. Use information from the EPD for the product to be used, or if you're looking at early doors, the TDUK weighted average data to calculate your embodied carbon impacts. And then incorporate those circular economy design principles to reduce the carbon impact. So that's the key actions we want to take away from today. We have got there will be a poll at the end for feedback, so I won't dwell on that. But we'll take a few of your questions now, because I know I've seen some questions coming in. So we'll move over to those for the last. We've got 5 minutes left. So just move over to so Michael. It was stated that the only way carbon is released to atmosphere in construction timber is by burning. Well, we did say it was either burning or decomposing. If the timber is allowed to decompose, then the carbon will be released. Yeah, not necessarily. If the timber does decompose, it will release the carbon back into the atmosphere. But there's been a lot of studies in Australia and America which show that actually timber in landfill doesn't actually decompose. A solid piece of timber in landfill, the atmosphere that it's in there doesn't actually decompose that much. And actually, when they've started doing mining of landfill sites in those places now, they're pulling out almost solid pieces of timber from those landfill sites. So there's a bit of a debate whether all that timber will actually decompose. And actually, what the data says now is if it's going to landfill, it's deemed to have gone back to atmosphere after, I believe, 100 years. So anonymous attendee said, with faster growing tree species, does this mean that levels of CO2 will be resulting in lower levels? It depends on the the density of the timber. So if the timber is lighter, so if you've got something like a eucalyptus, that will have a lighter, that will be slightly lighter in a lot of cases. So yes, there will be less embodied carbon within that piece of timber. But that's not always necessarily the case around the speed of the tree, the speed of the tree growth. It's not directly related. There are some species which will have naturally lighter timber, but there are other species that will still grow reasonably fast, but still have quite dense timber. So it's not directly related, no. Aurelie, hi, is there a difference between certified and non-certified timber when accounting for biogenic carbon content in life cycle estimates and EPDs? As we mentioned there, I think we answered that question going through. Hopefully, if you're using certified timber, yes, just to reiterate, you can then include the biogenic carbon content in the whole life carbon assessment of the building or within the EPD. If you can't demonstrate that timber has come from a sustainable source, then you cannot include that biogenic carbon content in the EPD or the whole life carbon assessment. So if you are producing an EPD with uncertified timber, it's unlikely, but if you did produce one, you would have a very high carbon figure at the end of the day in that. So it does make a massive difference. Will we get copies, Douglas? Will we get copies of this presentation? Yes, Laura will send copies of the presentation around. I'll send her the updated copy because we only updated this yesterday because of the updated data from TDUK that's come through. So I will send her updated and get them sent around to you. One from Gary, I struggle to obtain EPDs for hardwoods. Can you advise where they can be obtained? Gary, I've also had exactly the same problem. There aren't hardly any EPDs available for hardwoods, I'm afraid. The key reason for that, I believe, is because a lot of the hardwoods are produced by smaller organizations, and EPDs are quite expensive to produce. So the only ones I know about, if you go to the TDUK website, click on sustainability in the EPD database, that you will find some hardwood EPDs in there, but there's only about 3 that I know of. There's 2 for tropical timber, and 1 for some I think oak. I think it's oak flooring from Latvia or somewhere around there, one of the Baltic states. But that's the only hardwood EPDs that I can find, I'm afraid. But those are if you want to look at them, they're the only ones I can find. That's all the questions that I've got on here. Unless anyone else has got any more questions, by all means, put them in the chat or the Q&A. If you've got any other questions, I'm happy to answer them. If not, for those of you who need to go, we're just coming up to 2 o'clock now. So thank you very much for your time. Hopefully you've enjoyed this session today, the CPD session. There will be a quick poll when you leave, just to say what you thought of it. It's only about 3 or 4 questions, so please, if you can answer them when you leave, that'd be great. Give us some feedback. But if you've got no more questions, thanks very much for your time today. Have a look at the PEFC website if you want to come to one of our other CPDs later on. We're running these, I think, every 3 months. There's going to be an open CPD on a different subject this year. So please look at the PEFC website for the next one, and we look forward to seeing you then. Thank you very much.